Yes, okay. Hello guys, my name is Konstantin Kladko. I'm the CTO of Scale. Today I'm going to talk about something really interesting, an Oracle. We have at Scale a new generation Oracle, which we just implemented, released on our mainnet. I'm going to tell you the story how this thing appeared initially. When you have a startup, typically you don't have solve problems that you don't have. You solve problems that you really have. And the story of this Oracle comes from a problem we solved for our system, and then we realized that the same solution could be applied to many other problems, and that's how this Oracle was born. So what is an Oracle? I actually wanted to do something funny, so on internet I just, there is like neural net, and you can type whatever into the neural net, and essentially I typed, I'm a chain, and I always tell the truth. That's kind of a definition of the Oracle, and that's how the AI sees the Oracle. Very pleasant face, so that's the Oracle. First of all, I just wanted to ask you guys a question. Please raise your hand. Do you know what an Oracle is? At least have a vague feeling, right? Does anyone know really, really well what an Oracle is? Can anyone implement an Oracle, write a code, compile? No, okay, I'll tell you. Okay, there's one guy. So it's actually it turned out for us to be not so complex, although we did it the first time. So first of all, I'm going to tell you about typical oracles or Gen 1 oracles. A static oracle is just something hopefully decentralized, which feeds information into blockchain, and typically it feeds the same thing periodically, something which is called a feed. You keep on feeding the same thing. In 90% of cases, this thing is a token price. That's how people want to protect against market crashes. You have a collateral. If the market crashes and the price goes down, you're supposed to actually sell the collateral. This actually never goes well, because at exactly the time market crashes, the Oracle will not be able to feed the data because the network is typically congested. But that's kind of a different story. So guys like Maker, Synthetics, Avi, many other guys use Oracle for these purposes, just to report the token price. So we at Scale, when we started with oracles, our network is pretty complex because we have an internet of blockchains. We at the moment have probably one of the largest ever sets of smart contracts in our network, many of them running on Ethereum mainnet. And when we pretty much have anything and everything in our network, so at some point we needed to have an oracle. And the reason we needed to have an oracle was that if we are moving money from one chain to another, from Ethereum mainnet to Scale chains, and we need actually users to pay for it. But when the user moves a token from one chain to another, the destination chain doesn't know how much gas was spent on the source chain. So essentially, there's a problem of transferring information from blockchains, in between blockchains. And then we said, okay, well, we use an oracle for this, and we tried existing oracles, and it just didn't work. And then for our own, basically, purpose, we created a different type of an oracle, and then we later realized that it could be used for other things, and now it's actually running on Scale mainnet. This is something that we called a dynamic oracle. A dynamic oracle is where you can actually provide dynamic, real-time information about anything on demand. So it's not like you're feeding the same information periodically into the blockchain. It's more like a smart contract wants to know something at this moment, and you want this information to be in a smart contract. That's what's meant by being dynamic. And then one huge application that we realized of these dynamic oracles is something which people now call soul-bound tokens. Basically, that's the idea that you have many NFTs. These NFTs may be on different chains, right? And these NFTs actually determine who you are. They allow you to authenticate. They allow you to have some privileges in dapps, you name it, right? But the point is that you are sitting in your dapp, and these NFTs are on other chains. And the question becomes, how does the smart contract know about NFTs that may actually be stored on other chains. And that's where this dynamic oracle can be used. Dynamic oracle can actually tell a smart contract on chain A that the user has this particular NFT on chain B. That's one use of dynamic oracles. And then, as I mentioned, many others, kind of smaller users, gas reimbursement, prediction markets, games, whatever. So now let's talk about how this, so basically what our oracle is. First of all, it's free. You don't have to pay for it. It runs on Scale network. It's integrated into each Scale blockchain. It's decentralized, probably secured as a mathematical model under which you can prove security, and it can retrieve any information from any web JSON endpoint, and also from Ethereum mainnet, and also from Scale chain. So it can actually pull information from a variety of sources. So how does the oracle work? The first step, you have a client, right? Typically, a client is a browser or mobile app. And so the first thing that the mobile app or the browser needs to do is to request information. Let's say in this example, you want to find out the current time, right? You want to, from real time API, you want to pull the current time in a particular time zone and push this information into a smart contract. So the first thing, you form an oracle request, and it's kind of a JSON request, and you send this request into all nodes of a blockchain. So essentially, your blockchain becomes also an oracle. It's an integrated thing. Oracle and blockchain become glued together. So each node of the blockchain gets this request, this very simple request. You just want to pull this information. And then the second thing happens that each of those guys, each of them, sends the request. So in this particular example, there are 16 nodes in the blockchain, so there are 16 requests. They send 16 requests, and then what happens after each of them gets a response, this node signs the response using its key and sends it back to the user. So the user potentially can get 16 responses back, although there's no need to actually wait for so many responses, because it's a very simple mathematical theorem. Let's give you an example. Let's say you know that in a group of these people that we are sitting here, 5 people are liars, right? And the question is, you want to find out what the current weather is. You need to ask 6 people. And if all of them give you identical response, this will be correct result, because out of 6, only 5 can be liars, so the one of them was honest, and then you got the correct response. So basically, that means that the browser on the mobile app needs to wait for t plus 1 identical responses, where t is the number of liars in the system, the maximum number of dishonest or Byzantine nodes. In this particular system that we have, the mathematical model is that 1/3 of the nodes, maximum 5, are bad guys. So if you get 6 identical responses, which are coming from the nodes, then you know that the result is correct. And then that's basically the oracle result. So that's how the oracle result looks like. You see it on the right. It's basically the result of what the current time is. And there are at least six signatures of each of those 6 nodes. So that's the oracle result. And the last thing you do, you push now you have this result, the current time, you push it into the smart contract, and then the smart contract can verify 6 signatures. That's step number 1. Step number 2, the smart contract also verifies the time. We have, in every response, we have Linux time, because information can be stale, right? Like the current weather is not the same as weather 2 months ago or 2 months in the future. So oracle result only means something if you know the time, and there is some time jitter allowance that the smart contract can make. So the smart contract actually gets the result, verifies the signatures, verifies time, and here you are. You actually have the current time. So in this kind of a toy example, but you could actually get anything. You can get current time, you can get which NFT a particular user has on a particular other blockchain. You can get information how much money the user has, pretty much any information which can be pulled either from a centralized endpoint or from a blockchain. And in addition to that, let's say you don't really believe this, trust this time server, you could also average out. You could say, okay, there are 10 centralized time servers in the world. You could actually pull information, oracle results from all of them, and then inside of your smart contract, you can do additional averaging. calculating the mean, whatever. So there's also a way to make things more decentralized by actually accessing multiple independent endpoints. That's the Oracle. So as I mentioned, the Oracle is already running on Scale network. One additional kind of interesting thing about the Oracle is that there is also one thing, when you send a request, you also add a POW, a little bit of a POW that your browser computes. And the reason for that is that we don't want to protect against denial of service, essentially. Our Oracle is free, but to send Oracle requests, you need to actually provide some POW, proof of work, just to be able to protect against denial of service. Okay, there's the Oracle. So, last thing I wanted to tell about, Scale Dynamic Oracle runs on Scale mainnet version 2.0. It's fully operational. You guys are welcome to try it. Try it now. So we have some improvements coming soon in version 2.1 of Scale. People asked for, in the first edition of Oracle, we had JSON-based results. Now people asked us for ABI-encoded results, just because ABI encoding is easier to use inside smart contracts. And then you can get more info on our documentation, docs.scale network. That's it, I think, and I would like to thank you guys. And if you have any questions.
Were there any nuances for the integration?
Yeah.
Okay.
I found this on the web.
Quit listening, Siri.
Okay, I don't need to answer, I think.
Not asking you. Were there any nuances for the integration as it, regarding it being EVM on Scale as opposed to an Oracle on the mainnet?
The good thing about Scale is that we have this set of public keys. So Scale chain knows about all of the public keys of all nodes that the Scale chain is composed of. And that's why it's easy to verify the signatures. But in general, actually, the funny thing about Scale Oracle, you could actually use the Oracle for other chains. Like you can get this result, there are 6 signatures. If you, before that, if you actually push the public keys into your chain or into Ethereum mainnet, this Oracle could also be used on the Ethereum mainnet if you trust the public keys. So if one wants to do a mainnet application, the only thing one needs is to actually push these public keys from a Scale chain to the mainnet. Okay.
Were you saying the POW field protects the nodes from being DOSed or the downstream API service from being DOSed? Because if you've got 10,000 nodes running and 100 users all requesting that API at once, how do you protect the downstream service from sort of being DOSed?
Yeah, that's a good question. So then, essentially, the downstream endpoint needs to be cooperative, right? The downstream endpoint needs to be accepting lots of requests potentially. So that's, I think it's kind of a thing which is a little bit beyond what we can do. We can just tweak POW a little higher, I think. But I think we really need at least endpoints that are able to process lots of requests. But the interesting thing about this Oracle, actually, you could actually use it for many, many interesting things, because literally it could pull information from anywhere on the internet. So you could do things like prediction markets, pull some news sources, essentially anything from real world you can pull into a smart contract.
And high level, how do you calculate bad actors?
So we actually, because Scale by itself is a provably secure blockchain, so we have a provably secure consensus. Our consensus is provably secure under the assumption of less than 1/3 of the nodes being malicious, BFT, Byzantine fault tolerant. In reality, it's 3T plus 1. So for a chain of 16 nodes, T is equal to 5. So you have 3 times 5 is 6, plus 1 is 16. So we already have a mathematical model for the security of consensus. So we just take the same model. So if there are 6 nodes in a Scale net which are malicious, then they will be able to not only kill the Oracle, but also get the chain to stack. So that's why we're taking the same mathematical model, which is basically the same mathematical model as the one which is accepted by TH2. Actually, there's a mathematical proof of the fact that in the asynchronous model of a blockchain, it's not possible to create a proof-of-stake blockchain with more than 1/3 of Byzantine fault-tolerant nodes. So it's actually this 1/3 is the highest possible thing mathematically, because there's a mathematical proof. If you have more than 1/3, they will be able to at least get it stuck, the blockchain. So asynchronous model means that your network can be arbitrarily slow. You know, so that in this model, 1/3 is the maximum. If the network has provably fixed latency, then you can go from 1/3 to 1/2. But then the blockchain becomes less robust, because if there is a period of longer latency, then the model completely breaks.
Cool. And are the malicious nodes, are they like slashed or punished in any way, or just ignored?
So actually, it's a really interesting question. So it turns out that in our blockchain, there's no need to punish malicious nodes or slash them, because if there are less than 1/3 of them, then even if they are malicious, they can do no bad. The mathematics protects, so we don't actually slash nodes because of this. If there are more than 1/3, then there's no point slashing them, because they will just kill the blockchain. So you're slashing on a blockchain, so there's really no point of actually slashing if the blockchain is already killed. So the slashing is really actually not such a powerful thing, because especially slashing is a post factum thing. You already did something bad, and you're supposed to get slashed. But actually, by the time you're slashing someone, the thing may not be exist already. So you're welcome. Thank you for the question.
All right. Time for one last one. All right, let's do one last one.
Thank you for the presentation. One question: why have you spent? Because building an oracle is not an easy thing. Why have you spent a lot of time building an oracle instead of use one of the different oracles that are already existing, and they are just focusing on solve that problem?
I can tell you the story. Like when Steve Jobs was already really sick, the guys from Dropbox actually got to him, and they wanted to sell Dropbox to Apple. And so there was a conversation, like it's a known story. There was a conversation between Steve Jobs and Dropbox guys, and the guy said, whatever, $3 billion. Steve Jobs said like $3 billion. I don't remember the number, but $3 billion. And the Dropbox guys said, no, $4 billion. And then Steve Jobs said, no, I'm not going to pay for $4 billion. And then Dropbox guys like, why not going to pay $4 billion? And he said, you know, guys, because what you have is not a product, it's a feature. You know, file storage it's not an independent product. It should be a feature of larger thing. So there are actually, you know, it's questionable. We have all kinds of oracles at scale, but there is an argument that some people want to have integrated oracle integrated inside of the blockchain, because if the oracle is integrated, then if something bad happens, it's easier for the oracle to report results. There were multiple cases where the market crashes, oracles are trying to report the results because the collateral needs to be sold, but that's the time when the network is overloaded and congested, and oracle is just not able to pass the transaction, essentially, to report the result. So there are arguments that maybe oracle needs to be part of the chain in some cases. But this is just the thing that we created also, as I mentioned, because there was no solution. Existing oracles didn't provide us even to solve a problem of gas reimbursement. So we just created it because we needed it. I think in general, you know, people will see. Some people use internal oracles. You know, good thing about external oracles is they're just like specially designed, maybe better code, whatever, more time spent. So.
I think that's going to wrap it up, but thank you again so much for your time in the talk today.
Thank you, guys. Thank you very much.